So hi, I'm Scott Jessen. I'm the Director of Product Development with Tenant Products. What we wanted to do is take some time. We have a bunch of questions that we get often. And what we're going to do is share some of that research, some of those findings. We're not the experts, but we are continuing to try and increase our knowledge and improve that. And we wanted to share some of those notes with you. One of those things that we get often is sugar in the brain. And how does sugar affect the brain? How does it work in the body? So what we've put together is actually a group of terms, and we're going to look at how sugar actually works in the body, look at our glycemic index, look at how sugar and sugary foods work, and then different sweeteners, what actually works for the body, what works for the brain, and how it functions. So one of the terms that we actually find when we look at this is how does sugar work in the body? The glycemic index comes up a lot. So the glycemic index is a value that's used to measure how specific foods increase blood sugar levels. Now, what's interesting about this is it's almost being phased out now. It still comes up a lot, but this is looked at as how one food acts in the body. And foods are classified as low, medium, or high glycemic foods, and they're ranked on a scale of 0 to 100. The challenge is we often don't consume the foods one at a time. We usually use them with other things included. And so this tool has started to see its way out of normal use. Although if you do see this glycemic index come up, it's a specific rating system that a specific rating system for foods containing carbohydrates. Basically, it shows how food affects your blood sugar or the glucose level when it's eaten. So some of the high glycemic index foods that we're looking at sugar and sugary foods, sugary soft drinks, white bread, potatoes, white rice. If you think of those really high carb foods and how those break down in the body, folks will say, hey, did you know that a loaf of bread can actually work the same as a bowl of ice cream on your body, and it still turns to sugar? They're talking about the glycemic index and how your body reacts. So when we look at low or medium glycemic index foods, we're looking at, again, some carbs, but like broccoli and cruciferous vegetables are carbs, but they're lower on the glycemic index. If we look at whole grain foods such as porridge and oats, this also depends on how much they're processed, if they're highly processed or unprocessed, and then how they actually work in the body. So when we start talking about sugar specifically, we're going to be talking about glucose, fructose, sucralose, and sugar. So I guess the question is, we've asked, hey, how does the body process this, but can the brain process glucose? Well, this is a little controversial because some folks say that the brain doesn't actually process it or that it doesn't process it well. And it really depends on what is happening in your body. What we do know is that the brain consumes about 20% of the body's glucose, but the brain runs better on fat. Neurons have the highest demand, requiring continuous delivery of glucose from the blood. And the brain, even though it's a small percent of the body weight, uses about 20% of the energy consumption. The challenge is when glucose isn't present and it fuels this function, it can run into some problems. So, and this is a direct quote from this study, but tight regulation of glucose metabolism is critical for brain physiology, and disturbed glucose metabolism in the brain underlies several diseases affecting both the brain itself as well as the entire organism. In other words, if we don't have enough glucose present, we can end up with problems in the brain. If we don't have enough fuel for the brain, we can end up with some problems there. So we do know that glucose is essential metabolic fuel for the brain, and without it, it can quickly lead to impairment in the brain. So without appropriate glucose, you can end up with brain fog, or you're consistently looking for that word. And if you have a lack of glucose significantly in the brain and lack of energy, then you can actually end up with permanent, irreversible brain damage, impairment of cognitive function, autonomic failure, or seizures, or even loss of consciousness. So the bottom line is that sugar is good, but it's not always fantastic for the brain. There are some other substances that work really well. Dr. Mark Hyman seems to think that brain on the sugar is essentially depressed, demented, and hyperactive. And then he references He references kids at a birthday party after cake, sugar, and tantrums, and see exactly what that looks like. If anybody's been to a kid's, 6-year-old's birthday party, they understand exactly what this is like. It's the same thing for the rest of us. Drivers for sugar are mediated through multiple pathways, many of which have to do with insulin resistance, and its effect for cognitive function over time. And eating lots of sugar can actually turn into plaque. We've all heard the term amyloid B plaque or plaques, which eventually leads to Alzheimer's and dementia. Well, some folks are even referring to Alzheimer's as type 3 diabetes. And again, a study that actually links to that. We know that sugar and brain health is linked to attention deficit disorder, depression, misregulation of hormones, and creating a dysbiosis in the microbiome. So then we have a bunch of different sweeteners. What are we actually using? Is there a difference on brain health? Well, a direct quote from Dr. Hyman is sugar is sugar is sugar. But if we take a look at natural sweeteners like honey, maple syrup, brown sugar, coconut sugar, raw cane sugar, they're all very similar in the body with one exception, and that's fructose. So fructose is something that naturally occurs in sugar. It combines table sugar with glucose with a powerful bond, and then that fruit itself contains fructose, but it's in the matrix of the fruit, right? So this contains vitamins, minerals, phytochemicals, fiber, and that all pair with the fructose to adjust how well it's absorbed and offset in the body. If you think about just eating an apple or eating an apple with peanut butter, the apple with peanut butter actually has a lower glycemic index, and your body will be able to absorb it better because of the peanut butter. It's going to help balance those out. It's not that different when we're looking at things like the whole fruit versus just the fruit juice. When we have high fructose corn syrup, this is interesting because high fructose corn syrup contains glucose and fructose, but there's more fructose, typically 55 to 75% more. But this fructose is fructose free, which is more easily and quickly absorbed. High fructose corn syrup is ingested in soda or fruit juice. It creates significant changes in the liver, which can lead to non-alcoholic fatty liver disease. Fatty liver, raising triglycerides, but doesn't necessarily raise insulin levels or blood sugar directly. It does indirectly, however. So as the body continues to process this over time, it will actually increase these and cause some more problems down the road. If we look at honey, honey actually has more fructose than traditional normal sweeteners. And then agave, which is pure fructose without the balancing factors. It's an all-natural form of high fructose corn syrup. So it's accentuated in how it actually functions in the body. So just because it's natural doesn't necessarily mean that it's healthy, which is kind of an interesting thing when we dive into this and we look at how we even sweeten our products. So how does sugar work in the body? Bodies are designed for starvation. If we think about how the bodies were originally designed, they were really designed to store sugar. So if you think of a bear hibernating, right, it would eat salmon all throughout the fall as it prepares for, right before it goes into hibernation, sits down, eats a whole bunch of berries, basically creates, a hypertensive state and then goes into hibernation. Well, we do similar things, but our bodies don't necessarily process all of that because we don't go into hibernation. We continue to process this. So the problem is starch and sugars have similar effects on the brain and the body, and the body stores these as visceral fat, which is fat around the organs. You've heard the term skinny fat. This is essentially visceral fat or fat around the organs, which coats the liver, the kidneys, and the organs and produces all kinds of additional molecules. One of those molecules are cytokines. And this visceral fat that makes cytokines, interleukin-6, which is one of those, is fuel for inflammatory diseases like autoimmune disorders, kidney disease, dementia, and Alzheimer's. So now we have sugar that can't actually be removed from the body, and then it creates inflammatory effects, and we're starting to see some of those connections. So visceral fat also produces hormones and neurotransmitters and works with insulin to let sugar and fat into the cells, but can't let it out. So it's kind of a one-way pathway. In short, when we eat sugar, the body can literally shut down the body's ability to burn fat off the body, which slows the metabolism, creates inflammation, and causes hormonal changes in men and women. And this process causes the hippocampus to shrink, which is the memory center for the brain, and can lead to dementia, Alzheimer's, which some are referring to as type 3 diabetes. So when we look at true artificial sweeteners like aspartame, do they have significant neurological effects on the brain? We're talking about stevia, monk fruit, and allulose are still to be determined on how, we really need more data on how the body responds and the insulin response, deriving the secondary consequences for this, especially with inflammation and disease. But the preliminary data indicates that the responses aren't as bad as other artificial sweeteners. As artificial sweeteners, but many studies still need to be conducted. So basically, we need more data. We don't think that they're as bad, but we need some more data. Typically, whole food isn't the problem, though. It's the processed and complex sugars that are. So, well, what are we actually? Can we look at this in a real world example? And the body still has a response to sugar. If we think about Dr. Hyman's response, a sugar is a sugar is a sugar, or a sugar-like substance, even if it doesn't digest it, right? So if we think about the classical conditioning, an example would be Coke Zero, which would trigger the body to think sugar is coming into the body, so insulin is released. When insulin, which is an inflammatory substance, is released and can't find the sugar to target, insulin resistance can build up in the body. This is how we can have additional inflammation and can cause some additional problems. Then does sugar, stevia, or monk fruit have the same addictive properties as artificial sugars on the brain? And almost everything in the American diet has added sugar, right? We like to think about the standard American diet. It's incredibly sweet. But an example of that is one serving of Prego, if you actually look at that, has more sugar than 2 Oreos. One glass of orange juice has the same amount of sugar as a can of soda. These are pharmacologic doses of sugar, which can cause problems. And when we look at our population, we know that about 88% of the population is metabolically unhealthy. So what happens to the body with the sugar? It's eventually going to end up in the brain. So when we think about nutrition in the brain, or how the body processes glucose in the brain, we have hypometabolism, which is a feature of Alzheimer's disease, right? So an Alzheimer's brain has an inability to create or generate ATP, which is the energy of the cells. And it's diminished by about 50% when glucose is used as the fuel source. In other words, if you have an Alzheimer's riddled brain, it's difficult for your body to process glucose. What's interesting about this, though, is that the brain's ability to use ketones is unperturbed, which is one of the reasons why ketogenic diets have been used as a therapeutic option for Alzheimer's. If we look at the specific sweeteners and how they function in the brain, we actually see that stevia leaf sweetener, or stevia leaf extract, may actually improve overall cognition, and there are actually a couple of studies that show that it may help with cancer. The data show us that it's about 200 times sweeter than sugar itself, than raw sugar. It has been known to lower glucose and insulin levels when used over time. And from a manufacturing standpoint, it's able to give a consistent flavor profile for production. It's generally regarded as safe, and you see the asterisks there. And this is because commercially processed stevia, so something from PepsiCo or the Coca-Cola company, rather than stevia leaf, has been linked to studies related to non-nutritive sweeteners and the disruption of the microbiome, or the beneficial intestinal bacteria. What we actually are using in our products to sweeten our products, we've used both. We've used monk fruit and stevia leaf extract, and we found that stevia leaf extract actually works well from a consistency standpoint, from a production standpoint. And so it's not the highly processed, commercially processed stevia. It's actually organically grown stevia leaf extract that's coming from the whole plant. When we look at monk fruit's incredibly sweet, but it kind of maxes out on a consistency at a certain point. It's similar to stevia in that it's 150 to 200 times sweeter than sugar. It doesn't raise blood sugars initially, just like that, just like the stevia leaf. It has a low glycemic index, and it's generally regarded as safe. And so it has a similar impact on the body. We can still sweeten this. Both of these are natural, the stevia leaf extract and monk fruit, which is what we found. But the stevia leaf extract is actually more beneficial from a production standpoint. So then you say, okay, well, do we really need sugar or fat for the brain? Well, let's look at what happens with fat in the brain. And the human brain is nearly 60% fats. Fatty acids are among the most crucial molecules for brain performance and the integrity of the brain. And we actually need essential fatty acids, which are fatty acids that are required for brain health and function, but they can't be made by the body. If you think about omega-3, this is one of these. DHA is also something that's needed for visual acuity, mental development. And fat actually works to help support the brain structure, stimulation, and neurotransmitters. When we think about why the ketogenic diet works so well, and one of the reasons why we have ketones in MCTs in brain food is because the brain will be able to use those across the board. And lipids, or fats, play structural roles and functional roles in the brain. And this is how we've actually seen that their clinical relevance, that dietary fats are currently in use for treatment in brain diseases. And the bottom line for this is that whenever ketones are available in the blood, which are derived from fat, the brain will use them. Unlike glucose, right? Which, if you have a difficult time processing things in the brain may or may not be able to process that, but we know that it will be able to process ketones. The body doesn't have any biological requirement for grain, although the FDA food pyramid still calls for grains at a base. And we know that those will turn into sugars and then glucose, and the body may or may not be able to process them appropriately. Fat, on the other hand, is a requirement for the brain to function, and the brain feeds off ketones, which are produced by fat rather than glucose. And the liver health is also required for brain function. Sugar plays a key role in both liver support and the amount of visceral fat around the organs. So when we think about all of this and how sugar actually works in the body, if we use natural sugars or what actually works best for brain health, we know that we want to minimize sugars, especially those added sugars or commercially processed sugars, for optimal brain function. Decreasing overall sugar intake and increasing the quality fat can not only decrease inflammation, but increase fuel for the brain and cognitive function, regardless of your brain status. And then we want to stay away from streamlined fructose or high fructose corn syrup. This is one of the key factors for non-alcoholic fatty liver disease, triggering inflammation, visceral fat, which all dramatically not only impact brain function, but also the body. And then if we want optimal and healthy brain function to stay in the realm of those healthy fats and eating healthy fats when possible for sustaining brain function.